section of chapter 3. This is 3.9 differential. Alright, in many type of applications, the differential of y or dy can be used as approximation of the change of y or delta y. That is, delta y is approximately dy, or delta y is approximately f prime of x dx. Alright, I'm going to show you by example here. Alright, let's look at the first example. Use the information to evaluate and compare delta y and dy. Given, this is the given condition, y or f of x is equal to 2 minus x to the fourth, x equal to 2, and delta x equal to dx equal to 0.01. I'm going to work on the left hand side first. Delta y, alright, delta y is equal to f of x plus delta x minus f of x. So this is formula. So I'm going to plug it in. F of x, my x is 2. Alright, delta x, my delta x is 0.01 minus f of x. So it will be f of 2. My x is 2. Alright, now I'm going to simplify a little bit. This is f of 2.01 minus f of 2. Alright, so this is your f of x. So f of 2.01, I'm going to replace 2.01 in here. Alright, and the number that I get is negative 14.3224 minus f of 2, you replace the 2 in here, you're going to have negative 14. And if you subtract them, you're going to have negative 0.3224. Alright, now let's compare with delta y. Alright, dy, I'm sorry, not delta y. dy is f prime of x dx. So first, let's take derivative of this. Take derivative of this, you're going to have negative 4x to the cube dx. Right? My x is 2, so I'm going to substitute 2 in there. I'm going to have negative 4 to the cube. And my dx is 0.01. Alright, after you calculate this, you're going to have negative 0.32. Negative 0.32. As you can see, they're not exactly the same, but they're very close. So I'm going to say that delta y is approximately dy. Alright. Now let's look at the next example. Again, we're gonna exchange delta y and dy whenever it's appropriate. Alright. Now from the first equation here, delta y is equal to f of x plus delta x minus f of x. Since they're approximately the same, I'm gonna replace delta y with dy. Alright, then I have this one. I move things a little bit. Using algebra, then I have f of x plus delta x approximately f of x plus dy. I'm just moving a little bit here. And again, dy is f prime of x dx. Now let's look at example 2. Use differentials and the graph of f to approximate f of 1.9. I have this graph here, as you can see. They want to know when x is 1.9, what is y, alright? And this point is 2, 1. And I have a tangent line here, go to this point. And then cross the x-axis as 3, 0. Now, they want to know f of 1.9. I'm going to rewrite it as f of 2 plus negative 0.1, because this 2 minus 0.1 is the same thing as 1.9. The reason I'm doing that, I want to put in this formula. So my x will be 2, my delta x will be negative 0.1. And why do I choose 2? Because I know that when x is 2, y is 1. That's the given condition here. So let's using this formula right here. Alright, so I have f of x plus delta x, f of x plus delta x is approximately f of x plus f prime of x dx. Alright, my x is 2, that's why I picked 2 in the first time, because I have this information. So f of 2, so when x is 2, y would be 1 right here. When x is 2, y is 1. Now derivative of f prime of x. So because this tangent line, I have 2 points, 2, 1 and 0, 1. I'm going to use the slope. y2 minus y1 over x2 minus x1. So 1 minus 0 over 2 minus 3. I have negative 1. That's f prime of 2. So that's negative 1. My dx is approximately or equal to delta x, which I have it here. So I plug in all the information. I have 1.1. So for the graph f here, when x is 1.9, which is somewhere here, y should be about 1.1. Alright. Hi everyone, let's look at the application of 3.9. Look at the third example. The measurement of the base and altitude of triangle are found to be 36 and 50 centimeter respectively. The possible error in each measurement is 0.25 centimeter. Use differential to approximate the possible propagate error in computing the area of the triangle. Alright, so the formula for the triangle is 1/2 base times height. So let's look at the information here. We know that the base, right? The base is 36 and the height or altitude is 50. That's the given. Alright, the possible error in each measurement. So an error of the base can be plus or minus 0.25, and for the height would be plus or minus 0.25. So they can measure is off by 0.25, either a little bit bigger or a little bit smaller. Now they want to know that if you measure the base and the height off by 0.25, either a little bit bigger or smaller, how is that going to affect the area of the triangle? So what I'm going to do, I'm going to take derivative of this, right? So derivative of the area, alright. I'm going to treat the constant 1/2, leave it alone. So I'm going to use the product rule here. So first time derivative of the second plus second time derivative of the first. Alright, now I'm going to plug in the number. So 1/2 b times dh plus distribute 1/2 in h times db. Alright, now 1/2 is 1/2. My base is 36 and dh, alright, dh I'm gonna replace by delta h, which is plus or minus 0.25 plus 1/2. My height is 50 times dB. dB is delta B, approximately delta B. Alright, after this I'm just going to use calculator, and I have plus or minus 10.75 square centimeter. which means that if I measure the base and the height off just 0.25, the area could be off by 10.75 square centimeter, right? So let's look at the next example. The measurement of the radius of a circle is 16 inches. When a possible error of 1/4 inches, use the differential to approximate the possible propagate error in computing the area of the circle. Same idea, but now we have a circle instead of triangle. So the formula for area of circle is pi r square, and given radius is 16. The radius here is 16, and the change or delta r is an inch. So not an inch, 1/4 inch. All right. So they want to see what is the area, the error of calculate area. So I'm gonna take derivative of this. So derivative of the area would be take derivative of this. Pi is just pi, so r is the variable, so I have 2 pi r dr. Alright, now let's calculate this. 2 is 2, pi is pi, my r is 16, and my dr is approximately delta r, which is plus or minus 1/4. And I calculate this somewhere. I get plus or minus 25.13 square inches. So basically, if you miscalculate the radius by 1/4 inch, the area could be off by 25.13 square inches. Alright, so I finished chapter 3. So I will send you the procedure for the test, and I'll see you again later.